Hello dear students, welcome to my channel Chemistry with Chemist. So today I have come up for you all with a new video based on covalent bond. So we will learn about the definition, how to draw covalent bond, and we will also discuss about the properties of covalent bond. Okay, so without wasting time, let's start the definition first. Now covalent bond is the type of bond formed by mutual sharing of electrons. So whenever we talk about covalent bond, then there is always sharing of electrons. So this word you have to remember. Okay, there is always sharing of electrons. Am I clear? So normally we share electrons. And covalent bond, there is one property of covalent bond, that is covalent bond occurs between a non-metal and a non-metal. Am I clear? So when we talk about electrovalent bond, then it is between a metal and non-metal. But when we talk about covalent bond, it is between a non-metal and a non-metal. I hope you have understood. Now let's move on. Okay, now we will discuss or learn how to draw the structure of covalent bond. Okay, so first thing that I have taken here is the same atom. So let's come to hydrogen. Hydrogen is H2, that's why I have said same atom here. Now first of all, let me draw the configuration to hydrogen like this. So this is H and this is H. Okay, now hydrogen has got one electron in the outermost shell. This hydrogen also has got one electron in the outermost shell. Now for hydrogen we do not complete octet. Okay, it is not possible for us to complete octet for hydrogen. We complete duplet for hydrogen. I think all of you know this. Now if you look at this hydrogen and this hydrogen, how can we complete duplet? You all can imagine. See, if I transfer this, then what will happen is, if I have to transfer this, then you will observe that this hydrogen will not have any electrons, but this hydrogen will have two electrons. So this hydrogen will become stable, but this will not become stable. So transferring situation is not possible. What we will do is, we will share this two electron. Am I clear? This hydrogen and this hydrogen will come with a mutual understanding and they will share. So after sharing, how will represent them? I will write here H shared H. Am I clear? So in this way I will represent H bond H. So this line represents that I have shared one electron each from both sides. Okay, so let's take more example. I have given two more examples here, oxygen and nitrogen. Okay, oxygen I will draw it for you, and nitrogen I request you all to try at home. When we talk about oxygen, then see, it's 2,6 the configuration we need to know. We will only do the outermost. Now I'll draw the outermost shell. Then I have to draw a 6 electron. So 1, 2, 3, 4, 5 and 6 electron. Here also I have to draw 1, 2, 3, 4, 5 and 6 electron. Now you tell me, this oxygen will complete its duplet. So it is 2 electron shortage, and this electron oxygen is also having 2 electron shortage. So transferring situation is not possible here. What you can do is, you can fulfill this by sharing electrons. See, this 2 electron is shared. In the same way, this 2 electron is also shared. Now if you count for this oxygen, then it is 1, 2, 3, 4, 5, 6, 7 and 8 electron. Octet complete. In the same way for this side, 1, 2, 3, 4, 5, 6, 7, 8. So this oxygen also becomes stable. This oxygen also becomes stable. And how many electrons they have shared? They have shared 2 electrons. So how to represent that? Oxygen, oxygen, 1 shared, 2 shared. Am I clear? So this is the correct way of representing a covalent bond. And one more thing I'll tell you here. If you look at this oxygen, see, 1, 2, 3, 4 electrons did not participate in any of the bonding. So they will remain as pair. Okay. So we have to make a pair like this. In the same way, this side also, 2 electrons did not participate in any of the bonding. So they will remain as pair. And what is this pair known as? This is known as, I hope all of you have heard about this. This is known as the lone pair. Am I clear? This is the shared pair and this are the lone pairs. Okay, so in a covalent bond we have two type of electrons. One is the lone pair, other is the shared pair. Am I clear? So in this way we have to learn how to do this. Okay, now let's move on with new things. Okay, now we have different atoms. Different atoms means In the previous one, it was same oxygen, oxygen, hydrogen, hydrogen. But here we have taken different means different atoms are there in the formation of covalent bond. So HCl is one of that. Water. Okay. HCl is very easy. So I request you to try. Water, I'll do it for you. Okay. So H2O. So oxygen, I have to keep it in the middle. Okay. H2O, the element which is single, will always be in the middle, and more number of elements will be at the side. So oxygen will be there in the middle, and H will be on the two sides. Okay. Now we know that there are, let me erase this and let me draw the structure. It will be easy for me. So oxygen atom, I'll draw it like this. So 1, 2, 3, 4, 5 and 6. And hydrogen, there is only one electron, so one here. Hydrogen, there is only one electron, so one here. Okay. Now this oxygen, if has to be stable, need 2 more electron, and this hydrogen need also 1 more electron. So what will happen is this and this will form a bond, this and this will form a bond. So this hydrogen is also now completing its duplet, and this oxygen also has now completed its octet. If you count 1, 2, 3, 4, 5, 6, 7 and 8. Okay. So how will I represent this? Oxygen, 1 bond with this hydrogen, 1 bond with this hydrogen. Am I clear? And again there is 1, 2, 3, 4 electrons left, which has to be shown as pairs. Okay. So this is known as the lone pair, and these are the shared pair of electrons. So how many shared pair? 2 shared pairs. How many lone pair? 2 lone pairs. Am I clear? For oxygen. Okay, methane, and I have taken more example, carbon tetrachloride. Okay. So methane and carbon tetrachloride. So when you talk about methane, it is CH4, and carbon tetrachloride is CCl4. Okay. Now I will draw CH4 and show it to you. CCl4, you can try yourself. So again carbon in the middle, and hydrogen on 4 different sides, 1, 2, 3 and 4. Okay. We all know that hydrogen has got one electron here, and carbon outermost shell, it has got 4 electrons because the atomic number is 6. So again one sharing, I think all of you have understood now how to do sharing here, sharing this side and sharing this side. See, carbon has completed octet, hydrogen has completed duplet. Okay. How to represent? Carbon, 1 bond with hydrogen, 1 bond with hydrogen, 1 bond with hydrogen and 1 bond with hydrogen. So this is the correct way of showing covalent bond. Okay. So I request my students to try for CCl4. Now there is a topic called polar and non-polar covalent bond. Okay, so this is a very important topic. So when we talk about polar, I will show you here HCl. When we talk about non-polar, we have taken the example hydrogen H2. Okay, non-polar is usually between the same kind of atoms, and polar is always between the different kind of atoms. Why? See, if you think of a periodic table here, the elements which are on the right hand side, they have a tendency to attract shared pair of electrons. I hope you have heard this somewhere. Do you know what is this? Yes, I hope some of you are correct. It is electronegativity. So elements on the right hand side, they are electronegative. That means they will pull electrons. Okay. So if you look at these two examples, chlorine is here on the right hand side. So chlorine has a tendency to pull this shared pair of electron towards itself. Am I clear? So what will happen is the shared pair of electron which was between hydrogen and chlorine will be closer towards chlorine, this one like this. So what happens to this chlorine? Since it is pulling electron, it is pulling negative charge. Am I correct? That means this chlorine will get a partial negative charge, and this hydrogen will become a partial positive charge. But one thing is very clear, the bond is not going to break. The bond is not dissociating, only a partial negative and a partial positive charge is formed. Am I clear? But if you look at hydrogen, both are same. If this hydrogen pulls, then this hydrogen is also going to pull. What will happen to the electron that is shared? It is not going to move. It is fixed. That's why there is no partial positive or negative charge. Am I clear? So if you have a partial positive and negative charge like this, del plus and del minus, then that is polar. And if you don't have this partial positive and negative charge, then it is non-polar covalent compound. Okay. I hope I have made it clear to all of you. If you come to state, now the properties of covalent bond, state, since the covalent bond is formed by, you have to remember this word, weak van der Waals force of attraction, van der V and D here, WAAL apostrophe S. Okay, weak van der Waals force of attraction. Their state will be liquid or gaseous. Okay, melting and boiling point. Since the force of attraction is weak, melting and boiling point also will be low melting and boiling point. Am I clear? Conductivity, they will not conduct electricity, not conduct, or they will conduct partially, partly, okay, partially, because they cannot break into ions properly. Okay, ions, they were not going to break easily, that's why they will conduct, or we'll say they do not conduct also. Now next is solubility. So when I have to discuss solubility, then solubility is of two types. See, first of all, we have learned that covalent bond is of two types. One is polar covalent bond and one is non-polar covalent bond. Okay, so if it is polar covalent bond, then it is soluble in polar solvents, like water. Water is a polar solvent. Okay, and it is a non-polar covalent compound, then it is soluble in non-polar solvent like kerosene. Okay, so it is like dissolves like, means polar is soluble in polar solvent, non-polar compound is soluble in non-polar solvent. Am I clear? So thank you so much for watching my video. Please do like my video. If you find this fruitful, please share this for others, they can get benefited, and do not forget to subscribe my channel Chemistry with Chemist. Thank you.